So we're on page 95, and we are now going to compare the sample means of a dependent variable for two groups that differ on an independent variable. So this could be, in our case, someone investigating the gender gap, and we're going to test a series of hypotheses about the political differences between men and women. So the first hypothesis right here in 19 is that essentially men will give gays lower feeling thermometer ratings, which is again on a scale of 0 to 100 from cold to warm, than women. And hypothesis 2 is that men will give the Republican Party higher feeling thermometer ratings than women. So in statistics, we always have to test our hypotheses against a skeptical foil, which is the null hypothesis. So the null hypothesis claims that regardless of any group differences that a researcher observes in a random sample, no group differences exist in the population from which the sample was drawn, which essentially means that the null hypothesis is asserting that any observed differences in the sample can be accounted for by random sampling error. So the researchers' hypothesis, such as the gay thermometer and the Republican Party thermometer hypotheses, we consider alternative hypotheses. So we're going to learn a new function, which is called wtd.testC. And this permits us to test each alternative hypothesis against the null hypothesis and decide whether the observed mean differences between two groups are too large to have occurred by random chance when the sample was drawn. So here we have the syntax for our new function, wtd.testC. So let's run it. .testC. Our dependent variable is ftgr_gay. Our independent variable is gender, and our design dataset is NESD. So, as you can see from here, our T ratio is negative 8.1, and our P value is essentially 0. If you look in the book, you'll get a P value of approximately 1.9 to the negative 16th, which is something around 2 times in a quadrillion that you are going to get this again. So based on that, we can reject the null hypothesis. So let's run our second hypothesis through another weighted t-test and see what we find. T-test-C. Our dependent variable is ft_rep. Our independent variable is, again, gender, and we are using the same design dataset. So again, the information on ft_rep would appear consistent with the alternative hypothesis. Men with a mean of 44.57 score a little higher than women do, who average 44.32, a mean difference of 0.251, as you can see here. But does it pass muster with the null hypothesis? So if we look at the 95% confidence interval, which is negative 1.667 on the lower end and 2.169 on the upper end. So it does go through 0, the confidence interval does. So we know that the mean difference would occur by chance more frequently than 5 times out of 100. So there is a very high probability of observing a difference of 0.25. If in fact the null hypothesis is correct, 0.601. So essentially what that says is if the null hypothesis is correct, then we would observe by chance a sample difference of 0.25 about 60% of the time. So with that knowledge, we should accept the null hypothesis. So this is the last section of the chapter, and we're going to be talking about if we're asking a research question, not dealing with means, but rather comparing proportions between groups. So in our example, we're going to compare the proportion of male Democrats with the proportion of female Democrats. So in order to do that, we need to create an indicator variable using our as.numeric function. And then we're going to be able to use a different function called prop.testC. So the first thing we have to do is create an indicator variable, and what we're going to be doing here is converting the dem category of NES PID underscore 3 into our numeric indicator. So we take NES DEM equal as numeric, doing NES PID underscore 3 equals dem. So that has created our indicator variable, and now we're going to use prop.testC to evaluate gender differences in the proportion of Democrats. So here our syntax is right above us in line 30. So we use prop.testC, prop.testC, and then we're doing the data and our dependent variable, which is dem, and the data and our independent variable, which is gender. And lastly, we always have to do our weights. Don't forget. Okay. Among males, 31% are Democrats compared with 38% for females, which is a difference of 7 percentage points. As you can see from our 95% confidence interval, they're both negative, which means does not include 0, which already advises us to reject the null hypothesis. And then if you look at our Z statistic, it's negative 5.71 and has a p-value that is effectively 0, so 0.00. So it would be an exceedingly rare event for random sampling error to have produced the observed difference, which means we have to reject the null hypothesis. So this ends chapter 6. We'll pick up with chapter 7, which is all about chi-squared and measures of association. See you then.